Okay, so in this lab, we're going to set up an Ethereum smart contract using a test network. So in this case, we'll be using the Sepolia test network. So overall, you'll have to set up your wallet so that we can integrate with the Sepolia network. Okay, so I've already done this. So this is my wallet here. So we can see here I've got 4.5584 Sepolia Ether. And we can actually view that on the Explorer. So that's my transactions here overall, but we'll go back and we'll have a look here. Okay, so first thing we're going to do is to set up a very basic smart contract. So this is just a smart contract that's going to multiply, subtract, add two numbers, and also take a square root. Take a square, sorry, and also a square root. So let's see if we can do that. So the first thing that we do is we go to our remix. So I'll just start a new smart contract here. And I'll call it smart01.sol because we're using Solidity. And we'll just paste the code in for that. Okay, so there we are. There's a few warnings that we can just hopefully ignore. Okay, so the first thing that we need to do is we need to compile the smart contract. So we go to the compiler and we will just click on the compile smart01.sol and that will create the bytecode for us that will go onto the ledger. Okay, so everything is fine. There's a few warnings that we've got, but hopefully everything will be fine when we deploy our smart contract. Okay, so that's us. We've compiled it with the Solidity smart contract, and now what we'll do is that we'll deploy it onto the test network, onto the Sepolia network. And for this, we need the MetaMask wallet. Okay, so make sure you take a note of the compiler. So in this case, it's 0.8.26. And we're going to deploy. So for this, we're actually going to set up with our MetaMask wallet. So there we go. We'll set that up. And now we should be connected. Okay, so this is my Ethereum address on the Sepolia here. And you can see that the network is defined here. Okay, so what we'll do is we'll go and deploy this now. So this will actually tell us how much gas is required. This is the network fee here, which is 0.0045 Sepolia estimated to be able to deploy the smart contract. Okay, so we'll confirm that, and it'll take a little minute, but hopefully it will deploy soon. So overall, we can also use the Ganache Ethereum infrastructure to do a test network, but in this case, we'll actually use the proper test network. I can see now that it's actually happened there. We can actually go and have a look on Etherscan. And there is the deployment of the smart contracts here. Overall, there's the gas value that it's created. And this is my address here. And you can see the basic details of it here. There's the bytecode that's actually created on the ledger, so all looking good from there. Can have a look at the state and so on. Okay, so we've now deployed the smart contract, and we can actually check in our wallet to see if that's actually been confirmed or not. and we can look at our the contract on the ledger, and we can see that it's got an address overall that's been assigned to this smart contract. So here's the address here, and this is the contract that we've actually created. Okay, so we can have a look at the bytecode, so on. So we'll just get our deployed contract here. Okay, so we'll go and try and test it now. So we'll try and add two numbers, so 5 and 6. And you can see the answer is 11. We'll try to multiply two numbers, 5 and 6. It's calling up the smart contract, and we get the answer of 30. Take the square root, so we'll take the square root of 9. Oh, sorry, the square, and we get 81. We'll take the square root of 9. Hopefully this time we'll get 3. And we'll do a subtraction there. So 10 and 3. That's that there. Okay, so you can have a look at the smart contract code, but you can see that it's working well there. The other way that we can do this is that we can run Ganache, and for this we would link to our Ganache environment here. But what I'll do is I'll just get it set up so that we can use the real test network. Okay, so that's our test there. If we go back to our smart contract, so here it is here. So we have our contract, and this is the bytecode that we have there. And then what we want to do is we want to publish that. So it's just a single file, and I think we used 826 for the compiler, and we'll go for an MIT license here. And now what we need to do is to find our code and then paste the code in here. Okay, let me check. So that's the compiler that we've got, so that should be okay. Everything's fine there, and let's verify that. Just takes a little minute. And that's fine. So it's worked fine. We've got a few warnings, but that's actually okay overall. So everything looks good there. So we'll just analyze our contract. Okay, so it's got our details there. So we'll go back to our contract. And we see the main details there. So we'll go to our read contract and we'll try to see if we can test it now. So 10 plus 3, we'll make a query, and we get 13 there. So now we'll try to multiply 10 and 3, see what we get, and we get 30 square root, and this needs to be an integer, so we'll take the square root of 9, that works fine, and sorry, that's a square. We'll take the square root here, it's just 9, and that should give us 3, of course. That works fine. And then we'll do a basic subtract here. 10 and 3 should give us 7, hopefully. That's fine. Okay, so that's a very basic setup of our smart contracts. We could see that we could test it within Remix, but if we want to actually publish it, we need to define the compiler that we've actually used overall. Okay, so the next part of what we're going to look at is to create ERC20 tokens. For this, it's equivalent to create our cryptocurrency, where we're going to define a total number of tokens that we're going to create, and that's defined by the total supply. And then there'll be an owner of the tokens, and the owner can then allocate to a certain address. Okay, we also need a token name and a decimal value for the number of decimal points that we have. Okay, so we'll try this one here. Okay, so quite a big contract that we have. So we'll go back to Remix again, and now what we'll do is we'll add Smart 02, and we'll just paste in here. Okay, so this is our creator for our ECR20 tokens. So in this case, my symbol is ENU token, and the name of it is ENU token there. Okay, there's the total supply of the tokens, and this will be the address, which will be the owner of the tokens. So if you're doing this for your own lab, you'll need to make sure that you set your own Ethereum address to the right address here. Okay, so we'll go ahead and we'll compile this one. Okay, so it looks okay. Everything looks okay. That's fine. And then what we'll do is we'll now deploy that. So we'll just select the smart contract that we're going to use. Okay, so that's for our token. Okay, and then we'll just try and deploy that. Okay, it links to our wallet again, so it will tell us how much gas it will take to be able to deploy this, and that's great. So it's deployed perfectly. Okay, so we'll now go to our smart contract again. And it's just being created, so it'll take a little minute to be able to get our contract created. And here is our contract, and we want to verify and publish it. And the compiler version, so we'll just look back to see what the compiler version was. .24. Okay, we'll go for MIT license. Agree, and then we need to find our bytecode. Then we'll deploy that, verify it. Okay, and everything's been created correctly there. So here it is here. It's been successfully deployed. That's good. And we have an ENU token here. Okay, so up to now it's only been created here, and we can see the total amount of the tokens, who it's been allocated to, and there's a basic transaction. So what we'll do is that we'll now make a transfer of that token, and we can go back to our tokens. And I can now import our tokens. So I just need the smart contract address. Okay, so I've got an ENU token, and I'll import that in there. Okay, so that's my token imported. And what I'll do is I'll send this to another address. Let's see if we can find an address. Okay, so we'll send 10 tokens to this address here. Okay, so it just takes a little minute for that to go through, and that's been confirmed. Okay, so here's the transfer here this is the transfer here from this address to this address of 10 ENU tokens. Okay, so now I am the owner of these tokens, and I can now transfer them to someone else. Okay, so that's the element of creating your own cryptocurrency. And if you follow the tutorial, then you'll be able to understand, hopefully, how cryptocurrency is actually created. So in this part of the lab, what we're going to do is we're going to save the state. So the state means that the smart contract will remember in what state it's actually in. Okay, so we'll just copy some code as we did before. And we'll just go back to our remix. And I'll create another new file here. Called smart03.sol. Paste our code in. And if I remember, it's 4.10 and here. Okay, so in this case, we're going to, we have our functions of add and delete and show. So what we'll do is we'll keep adding, we can add values into the smart contract, or we can actually delete them. So this method here, show, will allow us to show what's in the array, or the values that we store from there. Okay, so let's compile this one. and that's compiled fine. So it's 4.18 is the compiler version. So let's go ahead and deploy that. It's just pending, so it just takes a little minute. Hopefully it'll get there. Okay, that's great. So we can actually have a look at it on our Etherscan. This is the address here. So there is our contract. What we'll do is we'll verify and publish. So we'll just verify and publish. 426. Yep. And we'll take an MIT license. And we'll find our code. Paste the code in there. And hopefully we'll be able to verify our smart contract and it will be deployed on the Ethereum test network. Yep, that looks great. Everything is fine there. Okay, everything's good. Just go and have a look at our contract now. Okay, that's all good. We'll go to our contract. Okay, so in this case we've got a write now. So the write allows us to be able to push data into the contract. So we'll add a value of 10. Okay, we've got to connect our wallet up because it's going to cost us some gas to do this. Okay, so we'll add a value of 10. And a value of 12. Now we'll read from the smart contract. Okay, let's try again. And we can see here, these are the two values that we've got there in there, 10 and 12. So we'll now delete a value. So we'll delete the value of 12. Okay. So now when we query, we will see the value of 12 has gone now. Okay, so in this way our smart contract is keeping the state. So we added values to it and we could show those values, and then we can erase a value within inside the smart contract.